Good afternoon, everybody, or good morning for some of you. Welcome to this workshop concerning the planetary boundaries and the links with LCA, and thanks for joining us. My name is Jade Garcia, and I am the director of SCORE LCA Association. And let me begin with a short introduction. For those that don't know SCORE LCA, just a quick overview. SCORE LCA is a French association created 10 years ago and gathering mainly big companies, as you can see at the bottom of the slide, and supported by ADEME, the French Environmental Agency. SCORE LCA is a collaborative research structure working on environmental quantification methods and focusing on LCA. And the goal is really to bridge the gap between research and practice, and to help first the members and then all practitioners to improve their LCA practice. Membership in the association grants many benefits. I will not read all of them, but for example, the shared cost, the access to practical results, and the specificity in governance, because it's really members that take all the decisions in the association. Finally, I wanted to show you that we have addressed a lot of topics since 10 years, some directly related to LCA methodologies, and some linking LCA to other fields in order to widen the scope of LCA. And most of our reports are available on our website. And there is also more information on SCORE LCA. So, but you can also send me an email if you want information or some precision. I also wanted to give you some technical information. Your mic and video, as you see, are cut due to the number of participants. You can ask your question in the chat, and Philippe and me will read it during the questions time. And the workshop is recorded, I think, yes. And the replay will be available on our website in a couple of weeks. And now I give the mic to Philippe Osset, our scientific director, who will present you the program of the workshop.
Thank you, Jade. Good afternoon, everybody. And so I'm Philippe Osset, Scientific Director for SCORE LCA. For those who belong to SCORE LCA and others, you might have seen already some publication. No, the screen is black, by the way. You might have seen some publications from our website, including elements regarding planetary boundaries. So I guess for most of you, it's not something new. But then we know that the method is evolving, and also the situation at world level is evolving with some planetary boundaries which are fast. And we have today two person who will present with Anders Björn, and I really thank him for being there today, an update on where we are now. And I think you are very, let's say, everybody is waiting for you. And also Martial, who will introduce some application within LCA of planetary boundaries. We have, as always in our workshops, we try to have sufficient time for question and answer at the very end. So I hope it will be quite interesting and rich. So, and with Jade, we shall select the question and help the presenters to answer them. So now I think, Jade, I will leave the floor to Anders. Is it correct? Yes.
Thank you very much.
Thank you.
Thank you for the invitation. I'm really excited to be here in this virtual space and have an opportunity to present for all of these participants. So you can hear and see my my slides now, right?
Yes.
Okay, wonderful. So I'll move on. And so the title of my presentation is Planetary Boundaries and LCA, Where Are We Now? And so there has been an evolution of the planetary boundaries concept. It was first described back in 2009 in an article in nature that got cited a lot. It got a lot of attention. Then 6 years later, in 2015, there was a sort of planetary boundaries 2.0, you could call it, which introduced some nuances. Some of the boundaries were calculated in a in a new way, and there was also excuse me. There was also the introduction of regional boundaries. I'll talk more about that later. Finally, last year there was a new publication, and there's going to be some work coming up this year or next year that is a bit different, because it's no longer about a safe operating space, but it's about a safe and a just operating space. So the idea is that there are some impacts that might be safe from the perspective of the Earth system, but it's not tolerable for certain vulnerable communities. And so that's really exciting to see what will come out of that. For now, it's more of a conceptual idea, but I know there's ongoing work. Also, 2015, there were two other important things that happened. The Paris Agreement and the definition of the UN Sustainable Development Goals. And both of those things are also about global goals that needs to somehow be translated into something that is operational for actors such as companies or nations. And so I see a lot of similarity with that challenge of translating planetary boundaries to lower scales, and what is also needed from the goal of the Paris Agreement and the UN Sustainable Development Goals. So to take a step back, this is a figure that was included in the first planetary boundaries paper from 2009, and it's basically showing the temperature on the vertical axis, and then thousands of years from now, so it goes back 100,000 years ago. And what you can see is that the temperature has really been quite unstable for most of this period. It's only the last 10,000 years that the temperature has been stable, if we forget about what happened the last 100 years with climate change. And so you also see on this chart that the last 10,000 years, which is what we call the Holocene, the time since the last ice age stopped. This is also where we saw the beginning of agriculture and the emergence of civilizations in Europe. And so there's this premise in the planetary boundaries concept that stability, a stable environment, is good for humans. It's good for our ability to develop societies and provide well-being in society and so on. And so we know that nature has not always been stable. There has been periods of very unstable conditions. And so the other premise is that humans are now like a geological force. We have the power, whether we want to or not, to change things in the biosphere to such an extent that it can be considered as a similar pressure as geological pressures. And that's why some scientists now suggest that we are no longer in the Holocene, we are in fact in the Anthropocene, because the changes that we see on the planet is mainly driven by humans rather than geology. And so when you put those two premises together, first being that stability is good for us, and the nature has not always been stable because of geological changes, and the other premise being that now we humans globally are acting as a geological force, then the idea is that we should really be careful not to change too much, because we could risk pushing the planet into another unstable state, which would be really bad for us. That's the premise, at least. And so this is why these planetary and also regional boundaries have been defined to essentially protect the state of the Holocene. And so there are 9 quote-unquote impact categories, because they are a bit similar to the impact categories we have in LCA, that each have boundaries defined, or at least there are attempts to define them. So what is between the boundary and the natural background conditions is called the safe operating space. This is where it's safe for humans to maneuver, you could say, to operate. So that's what I just indicated there on the figure to the right, the little green circle in the middle there. And these boundary positions, they have been calculated based on theories of thresholds and also resilience theories. So thresholds, for example, is this idea that we can pressure a system. When you start pressuring a system, there will be very little response, but then at some point there will be a quick response when you cross the threshold. So it's a non-linear system dynamics. And this is also how a lot of environmental systems are characterized. Also, there's a sort of traffic light style in the planetary boundaries framework to reflect uncertainties, because, for example, for the climate change impact category, it's actually uncertain if we have crossed the boundary or if we are still still have not crossed it, because we're in between the green and the red space. And finally, as you can see, there are a bunch of question marks. Some of these question marks are starting to disappear, but still, it's still not yet fully operational as a framework. There are some categories that lack indicators and lack specific boundary definitions. And I'll get back to that later as well. So how have planetary boundaries been applied? There was a really great review paper. It's from 2019, so of course it's not exactly new, but I still think that its findings are probably still valid today. They were looking at all the more than 3,500 studies that had cited the first planetary boundaries paper, and then they were trying to analyze what these studies were about or classify them. And they found that 71 of the studies related to application, related to somehow applying planetary boundaries for decision support, for solving some sort of problem. And so they did this keyword cloud word cloud, where these are all the keywords of those 71 papers. And you can see one of them in the middle at the term life cycle assessment. We're all quite familiar with that. So basically the paper showed that life cycle assessment is a central tool or method involved in applying planetary boundaries. So that's kind of interesting. But we can also turn the question on its head and say, why should we apply planetary boundaries with LCA? What's the sort of added value? Why do it? Why not just do a normal LCA? And I think the first reason is to answer questions like, so is that impact low enough? And what should we aim for? And this is where the idea of absolute environmental sustainability assessment and science-based targets come into play. And I think the other reason to apply planetary boundaries with LCA is to enable the calculation of a single impact score that reflects a scientific evaluation of the relative importance of different environmental impacts. And so this, in other words, this is weighting factors that are based on planetary boundaries. And it's important to stress that these are two different things. If you do one, you don't do the other. If you do the other, you don't do the one. It's kind of the road kind of branches out. And I'll detail that a bit later in my presentation. So first, absolute environmental sustainability assessment and science-based targets. So pretty much no matter what product or service that you can think of, you will probably realize that they have become more efficient, more eco-efficient over time. Just think about the production of light via a candle. which is how it was often done 150 years ago, versus today's highly efficient LED lights. It's really crazy how much more efficient the products have become. The same with heating and with the computing power and so on. And it's probably fair to assume that lifecycle assessment has helped to guide this process of improvements by, enabling the identification of hotspots and also flagging if there's some sort of burden shifting taking place across impact categories or across lifecycle stages. This is at least what we like to tell each other in the LCA community. The problem is that the state of the environment is really in trouble. These are some different state indicators. So, for example, concentration of carbon dioxide, nitrous oxide, and methane in the atmosphere, going back to 7050 up until 2010. And what you see in pretty much any indicator that you can see on this chart, there has been a recent, at least the last 50 years or so, there has been a quite recent increase in the state, the indicator value. So it's further away from its natural state. Sorry. And so the driver of those increases are essentially an increasing population that on average is more affluent, so more people on the planet, and the average consumption of people on the planet is going up. And this is something that's happening while the number of people that is starving on the planet is also increasing. So there's also inequality happening. The ones who have the most, they are increasing their wealth much faster and their environmental impacts than the ones that have the least. So another way of looking at it is that over time there has been a really large increase in the number of products and services delivered globally. And so even though each individual product and service has become more efficient, more eco-efficient over time, the increase in volume simply means that the overall impact has increased. So that's sort of an illustration of why better is not necessarily good enough, because better is what we usually do in LCA. We calculate or we estimate if one product is better than the other, but it doesn't mean that it's good enough. And in some sense, it's a moving target because of the increase in volume of products and services produced and consumed. It's always going to be a moving target how much more the eco-efficiency must increase to be good enough. So basically, the elements involved in an absolute sustainability assessment is to first consider the global safe operating space, and then assign a share, or allocate a share of that safe operating space to whatever you're studying. It could be a sector, it could be a company, it could even be a product. This is something that's also has happened within the global climate change negotiations, and also a lot of literature on climate change actually for more than 10 years has looked into how you can, in a fair way, allocate the global remaining carbon budget between individual nations using ideas such as capability and equality and responsibility. So it's not a unique idea to absolute environmental sustainability assessment. It's something that has been going on in other domains for a while. And then you would compare the assigned share or the allocated share of the safe operating space to the actual impact of the thing that you're studying. And obviously, if the impact is lower than the assigned share, which is what we see here on the figure to the left, then your thing you're studying is environmentally sustainable. That is rarely the case in practice. And so if the impact is higher, it's obviously unsustainable. And this is where you can then calculate science-based reduction targets that tell you exactly how much you need to reduce, and in some cases also how fast. Now, the other thing you can do by combining planetary boundaries and LCA are these PB-based impact weightings of environmental impacts. And so it really belongs to the type of weighting method that can be called distance to target. And so these weighting factors, weighting methods that are based on policy targets, they have been around since the 1990s. So they have kind of been part of LCA almost since LCA was born as an idea. But it's important to understand that policy targets do not necessarily align with planetary boundaries. This is a table from a study, Castellani et al. 2016, where she explored the relative importance of weights for different impact categories. If you consider the EU targets either binding or binding and non-binding, that's the first two columns, or if you consider the planetary boundaries, which is what she based on my publication at the time. And so one thing that you can see is that there's a big disagreement between the EU 2020 binding, non-binding targets and planetary boundaries with respect to the importance of climate change versus water scarcity, depletion of water. So the EU target had a much higher emphasis on saving water, on reducing water consumption, much higher emphasis on that than climate, whereas according to the planetary boundaries, it would be more or less the other way around. So yeah, but planetary boundaries can lead to quite different relative importance of impacts compared to policy-based distance to target. I should also say, and I'm sure our next speaker today is going to talk about that, but since my study from 2015, there's been some refinements of especially the normalization value for photochemical ozone formation that's no longer nearly as high. And also some of the ones where you see not available have since been estimated. So it's a more complete picture we have today of weighting factors based on planetary boundaries. And I'm sure Martial is going to talk about that. So how do you link planetary boundaries and LCA quantitatively? So far, I've talked about things in a more of a conceptual sense. So again, there are two ways of doing this. If you imagine you have a list of your elementary flows on the left, and then you have this planetary boundaries framework on your right. So the first way of doing it is basically to use the already existing characterization factors that has been developed within the life cycle assessment community. So these midpoint categories that are already been established, and then try to make them fit with the planetary boundaries. And in cases where there's not a planetary boundary, for example, for resource depletion, for example, then the idea is to come up with a similar carrying capacity that's also a global target, but it's not defined in the planetary boundaries framework. And so this is what I did along with my supervisor at the time, Michael Hauschild, when I was a PhD student at DTU. So essentially these normalization references, they allow you to normalize characterized results by per capita carrying capacity instead of per capita current impact. So they give you quite different information than traditional normalization references. And again, Martial, he updated that a couple of years later and made all the indicators aligned with the product environmental footprint rules. So to give an example of this way of this is an example of an absolute environmental sustainability assessment based on my normalization references from the time. So the functional unit is a typical Danish single-family dwelling with a net floor area of 128 square meters and an estimated service life of 50 years. And so the first step that they did in this study was to assign a planetary boundary or carrying capacity. So first there was an equal per capita allocation, and that was then followed by a final consumption expenditure allocation. And so that basically means that they looked at the statistics on what people spend their available income on, what different products and services that people spend their available income on, and then they saw what fraction of your income is spent on the housing. It could be the rent, it could be everything interior, and then based on that ratio, they assigned a share of the safe operating space or the carrying capacity to this functional unit of the dwelling. And so what they found is that I'm just showing parts of the results here because there's much more to show, but they found that the impacts basically exceeded the assigned share of the carrying capacity for 4 impact categories. Well, technically it's only 3 because there are 2 for climate change. So it's for land use, for climate change, and for freshwater eutrophication. And you see that there are two different product systems compared here. There's an upcycled house versus a standard house. And so you can see that the upcycled house, if we just take the example of climate change for radiative forcing indicator, the upcycled house is doing better because it's only exceeding the assigned impact by a factor of 10 and not a factor of 15 or 16. So it's doing better, but it's still not doing well enough, good enough. So that was just one example of how PBLCA can be applied in practice. So the other way that you can link the planetary boundaries framework and your list of elementary flows is basically going in the other direction. So you start with the impact categories and indicators used in the planetary boundaries framework, and then you develop characterization factors that link specifically with your elementary flows, with your inventory. So you sort of bypass the classical midpoint impact categories. And this is what my colleague at the DTU, Morten Ryberg, he did in his PhD a couple of years after I published my studies. So he developed new characterization factors for these planetary boundaries impact categories. And so the benefit of that is that decision makers that are more familiar with planetary boundaries than LCA, they will probably find it more convenient to work with those familiar indicators. One of the disadvantages is that the planetary boundaries framework doesn't cover impacts on human health, and it also doesn't cover abiotic resources use. So the depletion of minerals is not really covered because it doesn't directly threaten the stability of the Earth system. So that will also be sort of not part of a method when you base it directly on the indicators of the planetary boundaries framework. I should say there are a couple of other methods out there, including Gabor Doka, who has also developed a method that came out around the same time as the one by Morten Ryberg, and there are many similarities between them. Okay, and so the rest of my presentation has some examples of applications of PBLCA by companies. And so the first example is, I'm kind of cheating a little bit because it's not really PBLCA, but it's still I see it as a restricted version of PBLCA because it focuses on climate change, and it's only applicable to companies as the unit of analysis. And so that's the science-based targets, and the science-based targets initiative was established in 2015 based on a collaboration between some major non-for-profits and environmental NGOs. And they define a planetary boundary as, they define a science-based target as being in line with what the latest climate science says is necessary to meet the goals of the Paris Agreement, which is to limit global warming to well below 2 degrees above pre-industrial levels and pursue efforts to limit warming to 1.5 degrees. And I had a review paper that I recently did on science-based targets, and what you can see is that there has been a really rapid increase of the number of companies that have set science-based targets. On the left, you see the monthly number of companies. That's the stacked columns, and then on your right you see the cumulative number of companies. What you can also see is that especially during the last couple of years, it has become more and more frequent to set targets that are aligned with the 1.5 degree goal of the Paris Agreement, and it's become less frequent to set targets that are only aligned with the 2-degree goal or the well below 2-degree goal. And according to SBTi, as of the end of 2021, the companies that set science-based targets, their combined scope 1 and 2 emissions were roughly 1.5 gigatons of CO2 equivalents per year. And they covered 1/3 of global market capitalization. So that's basically the value of stocks globally. 1/3 of those were from companies with a science-based target. Science-based targets are still mainly set by companies with headquarters in North America or Europe, although some Asian companies, especially in Japan and India, are starting to also be more and more common in the data set. And to give an example, this is Coca-Cola. They set a target to reduce their absolute scope 1, 2, and 3 emissions 30% between 2019 and 30. And then in addition to that main target, they also want to reduce their absolute scope 1 and 2 emissions 47% between those 2 years, and scope 3 emissions they only want to reduce by 29%. So they are more they have a higher target for scope 1 and 2 than for scope 3. Microsoft has also set a science-based target. It's phrased in a somewhat different way. So they are committing to continue to annually source 100% renewable electricity up until 2030. And then they also commit to reducing scope 3 emissions. So it's the emission intensity per unit of revenue by 30% between 2 years. And I'm showing these two examples just to show you that there can be quite some differences in the way science-based targets are phrased. Differences in base year, in target year, in the targeted reduction, in the emission scopes that are covered between scope 1, 2, and 3, whether it's an absolute target or an intensity target. And finally, between the underlying sharing principles that are involved in the different methods that the science-based targets make available for companies. And yeah, this has really been my focus of research the last couple of years, is to better understand this phenomenon of science-based targets. And so I published 4 papers on this. You can Google me later if you want to check out the papers. Most recently, I published a paper in Nature Climate Change, actually last week, about the fact that companies with science-based targets, they use renewable energy certificates to claim reductions of emissions that are not really taking place. So yeah, encourage you to look at that as well if it's something that's relevant to you. So the second example of companies applying PBLCA is it's a pilot study, so it's not really an example of a company that has applied PBLCA in a sort of normal setting, because it was done as a collaboration between WWF, and so it was a bit of a special case, but I still think it has some really interesting outcomes. So the company is Alpro, which is if I'm not mistaken, is a Belgian company that specializes in producing basically dairy that's not from cow, but from alternative sources such as almond and soy. So, almond and soy milk and yogurt and some sort of butter and so on. And so here's from the report, here's just an illustration of the life cycle of producing almond milk, from farming over reception, processing, and drink formulation. And the life cycle inventory flows you can see here as well. And so in that study, they chose to focus on the farming stage. And because of that, they also focused on impacts specifically related to water use, nitrogen emissions, land use, and biodiversity. And so they looked specifically at 3 farms in northern Spain that are supplying the companies with the almonds that they use in their almond milk. And they did a life cycle inventory of each farm specifically, considering the data that was available and the environmental factors and so on. And then they came up with this. I'm simplifying things a bit here, but this is how they came up with a sort of traffic light evaluation of the extent to which each of those 3 farms, in addition to some soy farms, so the extent to which each of those are staying within their allocated boundary, or if it's likely to have exceeded or likely to have severely exceeded. And so what you can see is that, for freshwater and for nitrogen, most of the farms were doing fairly well. But for land use, both at the global level and the landscape level, and for biodiversity, it looked like they needed to reduce their impacts a lot to be behaving well. And so something I think is really interesting from this pilot is that they put a lot of emphasis on how to reduce impacts sufficiently. So after they evaluate that some types of impacts are too high from some of the processes in the life cycle, they came up with a scheme where they specify, for example, whether the transgressions of the planetary boundaries can be mitigated based on existing ways of managing and technological solutions and so on. Can we reduce emissions or resource consumptions sufficiently with this toolbox, with the impact mitigation? And if that's not the case, if transgression cannot be mitigated, then the idea would be to either relocate. So, for example, source your agricultural products from a different supplier, or to replace. And replace, I suppose, could mean that you sort of redesign your product so that it relies on a different material altogether. So I thought this was a quite interesting framework. They also had a focus on stakeholder involvement. So to what extent can the company who has commissioned the study, to what extent can they control the impact? To what extent can they influence the ways that the operation is taking place, if it's somewhere far upstream or downstream from them? To what extent can they play a role versus what are the other stakeholders that needs to be involved to work together to reduce impacts? And so this study was done back in 2019, and I believe that there's still work ongoing in the Science-Based Targets Network, which it's not the same as Science-Based Targets Initiative. The Science-Based Targets Network is basically trying to develop methods and guidelines that allow companies to set science-based targets for other things than climate change. And they have been, based on this pilot study and other inputs from companies and scientists and so on, they have been working hard over the past years to develop something that is operational so that companies can actually set targets for other things than climate change. But as you can see from this example here, it obviously gets complicated when you consider impacts that have a very local nature, and also where there's not maybe obviously just one single indicator to look at per impact category. So there's some ongoing and future work that is important to mention in this context, because the link between planetary boundaries and LCA, that there is a link now. There are some methods, as I've shown you, but they are not. There's always room for improvement. And one of the improvement needs is definitely to increase the spatial and also temporal resolution of assessments, because even though planetary boundaries are mainly associated with global limits to impacts, There's also many impact categories obviously have a very local nature to them. Think about water scarcity, for example. It can vary quite a lot between different watersheds, even within a single country. And so there's been quite some work going on in trying to increasing the spatial and temporal resolution of methods. I published a couple of years ago, along with Mon Ryberg and some collaborators from Unilever. We published a study called Life Cycle Assessment, Applying Planetary and Regional Boundaries to the Process Level, a model case study. And our approach was somewhat similar to that ALPRO pilot study that I showed you before, by looking at individual processes in a life cycle and whether or not those processes have impacts that are too high or low enough, instead of looking at the sort of aggregated impact across categories, because I think you do need to take a process perspective for those impact categories that have a very local nature, let's say. Then there's also new impact pathways that haven't been modeled before. This is just a screenshot from I'm co-supervising a PhD student at CIREC, Catherine Luke, who is looking at biogeophysical impacts of land use and land use change. So this is basically what happens when you change the land cover of a piece of land due to some sort of activity in your life cycle inventory. And that leads to a change in evapotranspiration, surface roughness, and surface albedo, which then leads to a change in precipitation, both locally but also downwind, and also in surface air temperature. And so the energy and hydrological balance is kind of changed as a result of a change in land use and land use change, land cover change. And that affects the planetary boundary or the regional boundary for freshwater, and also the planetary boundary for climate change. And she's in her PhD, she's really busy trying to model all of these interactions that ultimately result from a change in land cover. And that's something that will also eventually be included in an operational PBLCA method. Then there are some planetary boundaries or environmental limits where currently there's no estimated boundary within the planetary boundaries framework, planetary boundaries community. And as I mentioned before, abiotic resource use is one of those, so scarcity of mineral resources, essentially. So I'm also involved in the work with another PhD student at the CIREC. Her name is Wafa Babou. And I know that there's similar work going on in France at the SCTB with Nada Bendaman and Natasha Gondran, also looking at how to include resource scarcity in a PBLCA framework. And the approach that the WAFA is taking is very interesting. She's looking at the dissipation rate of minerals. So after you take in, for example, copper and aluminum, you take it into the economy from the ecosphere, then eventually it's gonna degrade and dissipate. So it's gonna become emissions essentially back into the environment. And when that happens, of course, emissions in themselves can cause environmental problems, but also the fact that it dissipates means that it's not available for use as materials again in the future. And so she's looking at these dissipation rates of materials, and she's also considering how much time different types of uses of materials in the economy, how much time is needed to transition from using one resource to an alternative resource when the first resource becomes scarce. So she's developing some really cool dynamic functions related to resource scarcity. That's all based on this idea that scarcity has to do with dissipation of resources rather than mineral deposits remaining. So yeah, interesting to see what will come out of that work as well. Then, as some of you might have seen, there was a lot of media on this a couple of months ago, where Persson et al. They tried to estimate the planetary boundary for novel entities, and they sort of halfway succeeded. I'm saying halfway because the boundary in the end was a function of the speed at which chemicals are studied or approved, going through some sort of screening process. So it's a function of the way humans organize in society, rather than some sort of absolute independent boundary. But at least there's more work ongoing, and I know also some recent publications coming out of DTU that also tries to take it a step further. And there are other examples of planetary boundaries or environmental limits that have recently been improved or estimated for the first time, but where more work is still needed. There was also, I forgot to include this on this slide here, but there was also recently a study coming out on a planetary boundary for green water. So green water, that's the water that's available to plants from soil. I'm probably not putting out the most elegant definition here, but it's an important compartment of water that has been not included so far in planetary boundaries framework, because the focus has been on blue water, so water that's flowing in rivers or in underground aquifers. So lots of interesting new developments going on. Also, I think that it's really important that all these methods, they eventually becomes operational, becomes usable to companies, consultants, and other users through integration with the databases and software. Because so far there hasn't been such a good integration of PBLCA with databases and software, and especially the aspects related to spatial and temporal differentiation put some potential new requirements on the tools, and also the dimension of principles for sharing the safe operating space. There's some different data that you need, for example, related to historical responsibility or equal per capita and economic contribution and so on. You need a whole different set of data than what is typically included in LCA data sets. And I think it's important that gets operationalized. And yeah, finally, it's really important to better understand what a fair allocation of the safe operating space is from global level, for example, to the level of a company. That there's methods are used all the time that assume some sort of allocation, but I always feel that there's not the allocation principles that are used in methods. They are rarely justified from the perspective of literature on justice or fairness, or even it could be interesting to do some sort of survey of different people or stakeholders to figure out is there some sort of broadly shared idea of what is fair, or at least are there broadly shared ideas of what is not fair, so we can not include that in our assessments. I think it's important to make that link as well. Finally, there might be a need to potentially adjust or realign PBLCA with what I call PB 3.0. And this is what I was presenting earlier as well. There's this ongoing work to define a safe and just Earth system boundaries based on as I understand it, is one single sort of unified model that they try to model a bunch of different boundaries within. And so it's a different way of doing things than what was done back in the last big planetary boundaries paper from 2015. And so new indicators will be involved, and that might also mean that there's some realignment that's needed from the PBLCA application side. So yeah, now we're at the take-home message. So a couple of things I would like you to take away from this presentation is that planetary boundaries can be applied in LCA for two things. One is absolute sustainability assessments and the setting of science-based targets. And the other is the weighting of midpoint impact scores. So far, I gotta be honest, there's been a modest uptake by companies. There has been a lot of development within the scientific community, a lot of papers published in scientific journals and so on, but there has been a modest, if not small, uptake by companies. But I do think, maybe I'm just being optimistic here, but I think that the success of science-based targets for climate change, which is now covering quite a big part of global companies, and also the fact that new methods are on the way from the Science-Based Targets Initiative network, and others. I think that could eventually lead to a higher uptake of planetary boundaries of PBLCA that goes beyond climate change. So yeah, thank you very much for listening. This is the end of my presentation.
Thank you very much, Anders, for this very interesting presentation. We have questions in the chat. Two first questions on the case study of Alpro. The first from Mélanie Bordignon. How do they take into account biodiversity?
Yeah, I think I cannot answer that fully because I basically screened the case study, and I haven't considered it very thoroughly along with the other literature that I've seen. What I do think that I can say is that they used a very local approach to. Sorry, I'm just gonna find again this slide. They used very local assessments of biodiversity. So looking at the species richness and the state of biodiversity very near the farms. And so this was the basis of the assessment. So it was not some sort of global average. But yeah, I encourage you to look into the study. It's quite long. It's like 120 pages or so, but it's really interesting to read.
Maybe I can provide some further insight.
Yeah, sure. Go ahead.
So again, thank you as well, Anders, for the presentation. It was very interesting and especially useful for me for the following presentation. So on the Alpro case study, what was done there is pretty much what Anders mentioned. Is for biodiversity, it's still a very high level kind of approach. So it's not based on anything like the global biodiversity score metric or anything like that. It's very specific to the areas that were under study and looking both at species diversity and ecosystem fragmentation. Someone mentioned like what was the scale of regionalization that was considered, and what was interesting is that for biodiversity, the people who did the study pretty much asked themselves the same question of what is relevant when we're talking about biodiversity. And so they did actually the assessment that, if I'm not mistaken, that 3 different scales in terms of looking at species diversity and fragmentation at 3 different scales. And of course, it really showed that you can have very different outputs and results, because when they looked at it in a very local perspective, pretty much at just a few kilometers around the farm, you had a lot of biodiversity loss and fragmentation, which is logic because you have a farm. But the minute they step out of that region and look a little bit further away, the effects were not as considerable. And so that is definitely, for me, one of the key points in the study is that we need to align across companies, academia, and governments on what is the best scale to look at biodiversity. Because if we go too granular, then of course everything is going to have a high impact. But if you go too high level, then maybe you lose some of the specificities that come up with that type of assessment.
Very good point. Thank you, Marshall.
And the second questions on this case study, how was the space allocated to the farming activity defined?
So that was also a little bit on an ad hoc basis, because for some impact categories, they used explicit. So the way I understand it, there were different teams of researchers were responsible for different calculating different impact categories. And so they did, in some ways, they were not consistent in the way they assigned the safe operating space. It was very much a pilot. They were very much trying different things out. So I think for some impact categories, they explicitly used, for example, For the water one, I believe they used something like, they tried out two different principles, one being something like contribution to economy. So the more you contribute to economy, the more water right you have, if I'm not mistaken. But I think most impact categories, they use implicitly, explicitly grandfathering. So they were looking at, are the impacts from all the actors that impact something, are the total impacts too high? If yes, if the impacts are, let's say, 50% too high, then they will also ask the individual almond farm to reduce by 50%. So the idea is that everyone should reduce by the same, so that's essentially grandfathering. Maybe Marshall, if you have anything to add here, I see you nodding.
No, absolutely. I agree with you. It is implicitly grandfathering, and I would say, just generally speaking, from what I've seen in other pilots that might not be public, or just the work that is being done as SBTN, that is the implicit assumption that is usually done. So it is looking at the state compared to the desired state in a region, depending on the scale that we are looking at, and then just assessing how far away from that target we are, and everyone is kind of implicitly asked to provide the same type of effort.
I think many science-based targets for climate change are also calculated using grandfathering, but there's one specific science-based target method that also takes into account other things, like in some sectors it's cheaper to reduce emissions than in others, and also if a company is projected to grow a lot their production, and another company is projecting to have a constant production, then that is also factored in with that method. So yeah, there are ways of building on additional principles in addition to grandfathering.
Yeah, maybe I take the next questions. We have two questions that I tried to merge, one from Yves Babian and the other one from Antoine Biotto, dealing with the facts, the difference between product level and corporate level, how to take into account growth of sales of product if we have targets at this level and so on.
Yeah, it's a very good question, because of course products are, as I showed in my slides, they tend to be, every year there are more products produced and consumed globally than the year before, and so you somehow need to factor in that growth in your allocation. One way it can be done is, for example, if you want to, in your study, in your PBLCA, you could both be interested in looking at, is the impacts of my product today high enough, low enough or too high? That could be one question to ask. But then another question could be, if my product doesn't change in 10 years, will it still be will it be low enough then, or too high? And of course you would also need to make assumptions about changing of the background processes, the energy mix and so on. But yeah, the time dimension is important here, because we are not in a static situation. And also the methods for science-based targets for climate change, they also have the added complexity that that emissions need to decrease globally. It's the goal is not to reach some sort of level where emissions are constant. The goal is to eventually go to zero, right? But there's a pathway taking us from very high, completely unsustainable level of emission to somewhere near zero. And so the dynamics of the boundary itself is like shrinking by every year, and at the same time more and more products are produced. So yeah, it gets really, really tough when you want to reduce your impacts efficiently.
Yeah. And maybe just in this line, a question from Jeanne Serre regarding, let's say, it's maybe more philosophical, but when you allocate to all products, then you don't question. And is it also a way to question the existence of some products, and because they cannot exist in the global allocation and in the limits we have?
Yeah, this is a very good question. I think we need to distinguish between the service delivered and the way the service is delivered. because there are obviously some products related to delivering energy, like fossil fuels. We know that they are not sustainable. That's just how it is. We need to transition out of fossil fuels, and I think if you do an absolute assessment that relates to the provisioning of energy, you will see that as a result that fossil fuels just don't have a place. There's no way that they can be. You can make them more efficient because they become carbon when they are burned. So there's a limit to how much you can reduce emission per delivery of service in that case. So yeah, some products will just never be able to become sustainable from an absolute sustainability perspective. Then there's the question of products where the service itself is questionable, like, I don't know, atomic bombs or other types of war things. And there are also things that are sold to humans that are not healthy to humans, obviously different types of drugs and so on. But then things get very subjective, right? It's already subjective in the first place when you talk about how to allocate between products. But when you also question what functions and services that should really exist, it's even more touchy, I think. But it's important. I mean, because in the end, sustainability is about meeting the needs of humans and without messing up the planet. And there are some products out there that do not really meet any needs.
Just to build on that, because I have one case study that I cannot share with you today. I had not planned for it, but maybe I can share some teachings or ideas that came out of that work stream. One way to think about it, because I agree with you, Anders, there is this value system in question at the end of the day, whether and it can be very basic. I mean, even amongst ourselves, we wouldn't agree. I'm sure that some people here online would agree that, oh, we don't need as many electronic gadgets, but I love skiing, so we should definitely keep skiing. And others would probably say the opposite. And so it is very hard to come to an agreement on what is needed, necessary, and valuable for society and what isn't. But one way to think about it from a company perspective, and an exercise I did, is that we can agree on some basics. So we can agree that we all need a space to live and we all need to eat. I would say those are two basics we would all agree on around the table. And there have been some estimates and projections on how much we can reduce the impact of housing and how much we can reduce the impact of food. And so that leaves us with, okay, so out of my impact, my own personal impact that I can have, there is already this piece that is taken by those two that are essential. And then the question is, how do you distribute the rest? And as a company, I do think that it's interesting in doing that exercise of taking your product, if you are working as a consumer-facing company, and thinking about, okay, what does this represent in the life of my client and my consumer, and whether that is sustainable or not?
Yes. The last question from Emmanuel, and I have no name, so I'll just say Emmanuel. I think make a good transition with the presentation of Martial. So I won't elaborate too much on it because I think it's a good introduction. Emmanuel Ilani, okay. Hello. That I know, by the way. And I think Martial will cover that point during his presentation. Just to know, can we use planetary boundaries for weighting within LCA, and what's the benefit of that? So I think it was the last question for today. So I mean, up to now for us. So I think I can, if Jad agrees, leave the floor to Martial for his presentation.
Yes.
So Martial.
Perfect. Well, I'll start sharing my screen. I don't know if I need to wait for you, Anders, to stop sharing yours, but I don't think.
Sorry, I'll do that anyways.
I can share.
Okay, it's working. All right.
All good. Super. Well, thank you everyone for having me as well. And again, thank you, Anders, because I do think that what you presented just right now really helped introduce the topic of the presentation that I wanted to make. And so today I'm going to tell you a little bit more about that weighting system that Emmanuel was asking about, whether we can use planetary boundaries as a weighting mechanism in LCA. Anders mentioned this is something that he started working on a few years back now, that I worked as well on a little bit later on, and hopefully it will be an interesting presentation of what that means and how could it be helpful, but also what are the limitations of this type of approaches overall. A little bit about myself first. So my name is Marcial Vargas. I am very happy to be with you today. I am currently the Global Innovation Lead at Qantas. What that means is that I'm in charge of all of our new developments, whether those are scientific or in terms of services. If you don't know about us, I did want to introduce quickly Qantas as a company. If I manage to switch slides, yes, I am. So our mission is really to work with our clients and transform their businesses in order to make sure that we align with planetary boundaries. And this is why I was very happy to have the invitation for today. Planetary boundaries is really the compass that we try to use when it comes to the type of work that we do, trying to push companies to be working at their best, aligning with them, and hopefully we can support them as much as we can. We do come from a past of assessing. We are, for a lot of us, experts in life cycle assessment, working in that space for a very long time. But we have extended our knowledge and expertise to also work on other things, such as defining and building coherent strategies, especially if we talk about aligning with planetary boundaries and working on a lot of the things that Anders was mentioning in his presentation, such as science-based targets for climate. We're also working with science-based targets for nature. Currently, I am actually going to be joining one of their MVP building workshops next week to try to come up with some of those first elements of alignment. We've been testing their approaches as well. So if you have questions around that space as well, I'm happy to answer them, even if they're not the main focus of what I'm going to share today. And finally, we also support companies on what we call their transform phase. So how do you implement all of this? I think this is something where a lot of the companies are still struggling because we can do all of this. We can assess, see how far we are from planetary boundaries. We can make commitments on what we want to reach and have those science-based targets that are relevant, as Anders was mentioning. But the real question that we have now is, what do we do now? How do we get to those commitments? What are the right projects? What is the right thing to do? And of course, we all know that's where it's trickier. I'm not going to focus too much on all of that today. The presentation was very focused and the theme very clear. I'm going to be mostly focusing on planetary boundaries in LCA and specifically on how it can be used for weighting, which was the project I was working on. I wanted to have a little bit of context, and so before I start, I'll thank, before I forget, the people who helped us carry out this project. One of them who is on the call with us today, if I'm not mistaken, who is Jacques Laidon. This was a project that was done by Qantas with the support and help from L'Oreal. And I'll tell you a little bit of the why. I think the context is important to understand, guide you through what we were looking for and why we decided to go for planetary boundaries as one of the best available options to do what we wanted to do. The context is quite straightforward. So I don't know how many of you are familiar with L'Oreal's previous sustainability strategy. They have since launched a new one, which was called Sharing Beauty with All. And as part of that strategy, which of course was very comprehensive and included a lot of other things, one of the main focuses was that by 2020, 100 of products would include innovations that would lead to an improvement from their environmental or social perspective. This, of course, meant, if we translate it into more pragmatic terms, that we were looking at eco-design, decision-making for product designers, and seeing how this can be actually put in place from a product perspective. In order to achieve that, this is where we came in and tried to provide some help, which is, how do we do that? And so the first element of this discussion has to go through what is called the SPOT tool at L'Oreal. So SPOT is a sustainable product optimization tool. And the goal thought is to be able to eco-design these products. And at the beginning, we had a lot of discussions with experts that included experts in LCA, but also experts on different methodologies that are not related necessarily to this type of approach, experts also on social issues, trying to understand what would be the best approach to make sure that products are more sustainable than they were before. And so that included improving packaging, improving formula in cosmetics, and making sure that that was the case. And what came out of that process is that what we wanted to have was a tool based on life cycle assessment, looking at the whole scope of the product, including the downstream elements such as the use phase, the end of life, based on the PEF indicators or impact categories, the whole list. And this is where it became a little bit trickier. We needed to have something that was decision oriented, meaning that we could not develop something that was very complex, where a lot of indicators were shown to the people making the decisions, and that created more confusion than it actually helped. And so this led us to have three main criteria when we were looking at it. The first criteria was that it needed to be a single score. It needed to be something that was efficient for product designers, because if they had still 17 PEF indicators, it would have made it very complex. There was also the possibility that some of this work might be used for consumer engagement, and in that aspect, it's also better to have something that is simpler. And so we needed to have something that really allowed us to focus our efforts on that single metric, which of course, as probably most of you know, as a lot of you are working in the LCA field, is something that can be very tricky because different weighting methodologies, and I'll discuss this in a few slides, have different benefits, different impacts, different ways of doing things. And overall, we know that it can create some problems, but I'll go into it in a few seconds. The second element was that the methodology needed to be PEF compatible. As I was saying, all the discussion that we had, both with internal experts at L'Oreal, external experts that we worked on during the project, experts at Qantas as well, came to the conclusion that we wanted to have something that looked at the whole list of impact categories that are in PEF, and again, using the same methodologies that were suggested by PEF. Which meant that the system needed to be PEF compatible, which has its own limitations because that means that we didn't have 1,000 options. The last one is that it needed to be science-based. This is something very important that we'll discuss a little bit further down the line, which is that we wanted to have a methodology to create the single score that was as transparent as possible based on science, and not something that could be easily criticized or that was maybe too specific to L'Oreal and the types of products that they are selling and developing. So those were the basic criteria. But when you think about it, and when you think about what do you want from a weighting system, it's not filling out all of this is not enough. There are additional features that are needed and almost indispensable if you want to make sure that it is usable as a decision-making tool. And so over there, we decided that there would be 3 key success factors in making sure that a weighting system was useful. The first one is relevance. And this actually goes to something that Anders mentioned a few minutes ago, which is the fact that you could have potentially a weighting system that works for all the other reasons that I'll explain later, but that doesn't actually put the weight on the most relevant impact categories from a global perspective and from a company perspective. And of course, this is something that you want to avoid, because if you start making all of your decisions based on the impact on, let's say, ionizing radiation, then probably you're not always going to make the best decisions for the planet overall. And this was something that we really need to consider, that the weighting system that is developed is really putting the emphasis on where we know, at least with our current knowledge, that there is the most critical aspects, the most urgency to address the topic from a corporate perspective. The second one is what I'm calling here dispersion. What you want to have when you're looking at a weighting system is a weighting system that actually does that. So that actually provides different weights and different values to different impact categories. Because if you look at a weighting system that weights all indicators equally, or creates just two main categories, for example, then it is not as useful anymore. Then what's the point of having a weighting system where all categories are weighted the same? In that case, you might as well just go to a way simpler approach where you decide what is in, what is out, or choose one or two indicators instead of going through all the fuss of having the system where you normalize and weight and all those calculations that get those numbers that are not interesting. Another one aspect to dispersion that I'm not mentioning here, mostly because the case study I'm sharing today does not show that, but that is important to consider, is that if you're in a case like the one that L'Oreal was in trying to develop a system that was for the whole portfolio, you want to make sure that the weighting system also leads to dispersion in terms of results. This is a little bit different, of course, because it's not dependent only on the weighting system, but also on other things. Because if you have a weighting system, for example, that puts a lot of weight on one indicator, that indicator is being driven by something that is common to all products, then you will have all products having exactly the same score, and in terms of decision making, it's not very useful. The last point is the specificity. So one way to look at whether a weighting system is interesting or not for a decision-making process, it is to look at whether the results that you get are different for different products. If you always get the same results in terms of distribution of impacts across the different impact categories, then it's not showing the specificity. It's not helping you make decisions, because if the order is, for example, always climate change is more important, then land use, then particulate matter, then water, then you might as well just focus on those four indicators, because that's always the answer to your question. So that might be the case. You might be in a company with products where they all have a very similar profile, in which case it is logical, but one might question then the whole weighting system. But if you're not, then you would expect that you get different results. So all of these are things that you're looking for when you're looking for a weighting system that makes sense overall. So this is just to provide you a little bit with the overall context of what we were trying to achieve. We're trying to achieve a single score system that was path compatible, science-based as much as possible, relevant in terms of highlighting the correct or the most critical impact categories, that was actually doing some type of weighting and not putting everything on one single bag or even two, and that was specific enough so that it would highlight the real challenges that different products face based on their composition, how they are produced, and all of those things that are product specific. In terms of specificity, one last thing I do want to mention as well is that ideally specificity shouldn't be only through products, but also industries. You would expect that different weighting systems would lead to, or a weighting system would lead to different priorities for different industries. So if you take, for example, a weighting system that would tell both an airline and a company producing or a company managing org charts the same impact categories as the most relevant or the ones to be addressed first, then again, maybe it's not as useful, because you really want to show that diversity, that maybe if you're an airline, you want to have more focus or more weight on things as climate change. But if you're managing org charts, then you should probably also consider things as eutrophication through nitrogen and phosphorus, because you might be using fertilizers, or ecotoxicity because you're using pesticides. So those are things to consider as well. Now, let's move into the next chapter, taking the first steps. So we have the context. We know where we wanted to go. The question then was, what do we do now? How do we get that going? Well, the first element, of course, is that the system needed to be classic. We didn't want to invent something too complex. And so we decided to go with the classic LCA approach. So meaning that our results would be first normalized to get something that was a reference equivalent, and then weighted through this weighting system. You could use planetary boundaries for either or. Actually, you can use it for normalization. You can develop normalization factors based on planetary boundaries, or you can create a weighting system that does this. And I'll go a little bit more in detail later, but just to give you a little bit of an insight here, the reason there were scientific reasons of terms of not having enough data to do a full normalization approach for all indicators, while a weighting system was more easy to put in place. I won't go into the details. I don't think I have the time to explain why exactly for each indicator this was possible or not. But that was one of the main reasons why we went more for the weighting system instead of the normalization approach through planetary boundaries. Now, let's question what we can do. So once we have decided this, that we want to normalize and weight, then the question is, what type of weighting system do you use? And Anders gave you a little bit of information on what is out there. I provided some examples of different weighting systems that exist. Things are binary. So binary would be things are either in or out. You could have a system that is panel weighting, which is you ask for expert opinions and develop an impact weighting system that gives different values to different impact categories depending on what experts think is relevant. You could have something that is more based on monetary value or damage weighting, meaning that you consider what is the willingness to pay for a clean or healthy environment, or what is damaging the most. Or you can have what we're calling a distance to target that Anders referenced, that has existed for a long time, and that can be based on different reference systems. So it can be based on legal action, what are governments pushing companies to do, or specifically on planetary boundaries. If we go through all of them, we can quickly understand or walk through why we decided not to use other options and decided to go for planetary boundaries. And I think the exercise is interesting to go through. The first one was binary and panel weighting. Well, binary, the first element, it is that it does not fit all of the criteria that I presented earlier. The first one being the relevance. So it is not pointing out to what is most relevant, or you could say it is. Maybe if you choose the correct ones, you decide that those are the ones that are relevant. But it does not create dispersion. You only have two different categories, so there is no dispersion in terms of which ones are more important than others. And that is something that we really wanted in our case. So that's why binary did not fit the bill. If you look at panel weighting, then the question really is how scientific can it be? And especially how can we ensure that we get some type of scientific external validation on the approach? Because if you look at panel weighting, it means that it will depend on the panel that was selected, the number of experts. Then you need to develop a whole system to be able to assess how they measure the importance, how you weight each opinion. Do you weigh them all equally? A lot of bias can be introduced through these approaches, and that is why we decided to exclude it quite early on. Then there's the monetary damage weighting. That could have been an option, considering that it was science-based as well. But it has the same kind of implications than planetary boundaries in some ways, because it means that you are able to define that monetary value for what is the economic consequence of those impact categories. And that also meant that the effort needed was probably equivalent or even superior because Anders' work was already published and we had more visibility on planetary boundaries. Then distance to target. So it did fit the bill on a lot of aspects. The main challenge was making it path compliant, because that was not something that was done at the time. We had Anders' work to start on that already provided a lot of information, but not everything that was needed. And what was missing were three things. so three main gaps that we identified as things that we needed to fill in order to have an approach that really answered all of the questions that we had and that I was talking about. The first one is that photochemical ozone was covered in Anders's assessment, but the first test that we did when we were trying out the methodology and seeing if it could work, it came out as being the main contributor to the impact of all of the products. And so by itself already meant that the methodology, we questioned whether it was the right approach, because it would mean that we wouldn't have that dispersion I was talking about. We wouldn't have different results for different products, which we're also looking for. And so we started questioning, and this is where we decided to test it even further and figure out that there was an adjustment that was needed. And the two big elements, the main ones that were of concern for us at the time, was human health and resource depletion. Both of these aspects have been traditionally excluded from planetary boundaries, both as the concept itself that was developed by the Stockholm Resilience Center, but also worked in LCA around planetary boundaries, has often excluded them for different reasons, but I do think it's important to highlight them. The first one on human health, which is one main aspect to it, is what is an acceptable burden when it comes to human health? I think that overall, when it comes to ecosystem integrity, we know that the ecosystem itself is still functioning. We consider that overall that is good enough, that we can accept that as the price to pay. We need just to make sure that the system is functioning correctly. If we are still destroying some specimens of a species, if we are still cutting down some trees, but that the ecosystem is still functioning, we consider that acceptable. For human health, it is a little bit trickier, because what is acceptable? Do we consider that some type of consequence on human health can be an acceptable burden or not? And so this is one of the main reasons why it was difficult to decide what to do in this space. The second one is on resource depletion. Similarly, here, there are different aspects contributing as to why it hasn't been considered. The first one is that you could, and again, might not be completely true, but mostly it is, you could extract all of the gold from the crust of the earth, put it in a room, and it would have little to no consequence on 99% of the ecosystems out there. And so it is not a challenge that has a consequence, or at least direct consequence, that is obvious on ecosystems. The main challenge of resource depletion is what is sustainable in terms of development of society, what is acceptable for future generations. And there is this question, there are those questions that start popping up of what is the dispersion of metals, for example. But the most important question is, what is the substitutability of metals? Because some materials we might be able to substitute them for others. And then there's a question of the use. Is the use something that is needed for society or not? So a lot of social questions that need to be addressed to be able to do that. And so what we did there for human health, and I won't go into the details again, I don't want to get too technical, is that we considered, and this has been since reused by other authors on how they think about human health and what is acceptable. We considered that right now, if you look at WHO guidelines, there is an acceptable limit, which is presented as the acceptable limit for particulate matter pollution in the world. However, we know that at that level of concentration for particulate matter, there are already consequences on human health. And so we consider that since WHO has that policy presented, then that could be considered an acceptable burden on society in terms of human health to build planetary boundaries around. On resource depletion, we used a different approach. There had been some work being done at CIREG at the time on what was a sustainable use of resources, and especially what would be a sustainable use rate for minerals, how it could be calculated. And so taking that into account and weighting different metals based on traditional LCA methodologies, we managed to create an impact category that looked at how sustainable is our current use rate of metals and minerals overall. And this led us to these results. So the ones that you have in the middle are the ones that were developed during this project. What you have on the left is the PEF current methodology. So the PEF methodology for weighting, or what has been suggested by the European Commission right now, it's a weighting methodology based on expert opinions. So they did 3 different panels with 3 different experts. They asked different questions, very complex, and overall they created this methodology. And what you have on the right is something that Anders did not mention in his presentation, probably because he's very polite and didn't want to cast a shadow over me, but there have been further improvements to the methodology that was developed then, or at least a different approach that was developed by Sala et al. So most work done by the European Commission, where they took Anders's work, my work, they changed some things, they used some different, they applied the same logic, but using different data on some aspects, and overall came up with a different weighting system for these categories of PEF. What you can see is that, of course, different weighting systems have different values that come out. There is some, at least, logic between some of them. So, for example, climate change is one of the most, if not the most important category for all weighting methods. There are other categories that still pop up on all of them as being more significant than the others. So things as particulate matter, things as land use, or resource use in general, whether it's fossil or mineral, or the combination of both, let's say, we can see that all of these indicators consistently come up as being slightly more significant than the others. There are other indicators that you can see are not fitting that bill, but that goes back to what Anders was saying. If you look at the planetary boundaries, and if you look at what people consider as being important, there might be a gap on some things. One of the most obvious that you can see here, it's that was already highlighted by Anders as well, can be on water. For example, you can see that if we look at a global level, and again, we're not talking at a very specific local level, but at a global level, water scarcity is not a challenge at a planetary level. But according to the experts that filled the surveys for PEF, they consider it to be quite significant overall. One thing I did not mention when I described, because it could be confusing, the reason why everything is in percentage is because it is easier to compare one-to-one if you have them all as percentages, as how much they contribute or how much you put weight as a percentage of the others overall, instead of trying to put values or raw values that are probably at different orders of magnitude and hard to compare. So anyway, different results to be expected, but overall you can see that it is aligned with, where you can already see here, that there are 2 things that are interesting. The first one is that we do fit the bill in terms of dispersion. We have different values for different indicators. There is a distribution among different impact categories, and we don't have all of our eggs in one basket. And the second one is that those topics that I was mentioning as being very critical, things as climate change, land use, particulate matter, are things that we know have big consequences on society. Climate change speaks for itself. Particulate matter is known as being the main cause of death linked to the environmental aspects overall on the world today. So it is logical that it would come up as very high. For eutrophication, in the case of planetary boundaries, we know that that's one of the main planetary boundaries crossed, according to the work of Johan Rockström and Will Steffen in the past. So overall, we see that there is some consistency on what planetary boundaries tells us and what comes up as being significant overall. So already some checks that we can put in there. Now, of course, we apply this, we look at different results. And if you look, let me show you first results. So these are results of weighted LCA results for a shampoo that are present in the scientific article that accompanied this work. And you have on the left the results of that study for the shampoo bottle with how much each impact category was contributing to the overall score or the overall impact of that bottle, and on the right, the weighting system. What is interesting is that while all the impact categories that have a high impact overall, so things as particulate matter, mineral use resources, or climate change, do come up as being contributing significantly, we have other things that are popping up that are not shown on the as being as significant according to the weighting methodology. For example, we have freshwater ecotoxicity that comes up as being quite significant in terms of impact. And this already shows that we have something that is more specific overall, meaning that different products, or at least in this case, the specificities of the cosmetics industry, and the fact, again, there are very conservative hypotheses behind these calculations, like the fact that we consider that all of the ingredients in the shampoo bottle would end up in nature, directly into water, but that's a specificity that other products like food products might not have. That's, again, very conservative characterization factors were used as well to assess the ecotoxicity. And that shows, meaning that if you have a product that was very toxic, again, not saying that shampoo bottles are, this was for the case study only, that would pop up. That is something that would be seen, even though the overall weighting methodology does not put that much weight to that indicator. And that conclusion is something that we also saw when we compare the results to another product. Here is a different product, which is a type of aerosol product. And what you can see here is that, of course, there are some impact categories that have high impact overall as the type of the weighting system we are using that still pop up. But what is interesting is that you have one photochemical ozone creation that pops up, which was not the case for the shampoo bottle. And it makes sense because if you look at the composition of aerosol and how you're using it, there are COVs, which are the aerosol part or the gas part of the product, that are being released when the user is applying that product. And so since COVs contribute to photochemical ozone, you would expect them to appear in some way or another, and that is the case. So overall, we end up with a methodology that does show those impacts and does show those results. Now, this is to give you, I gave you a high picture, and I want to go back. So take a step back as we come up to wrap up. So what does it mean? What do we learn through this work that we did and this PB-based weighting methodology? Well, I think that the best way to do that is to go back to the main criteria we selected. So relevance. We said that we would like a product that highlights the most relevant topics for a given product or company. I put it as a yellow, as a maybe, as a yes, but. So overall, yes, we see that the method that was developed for weighting does show different impacts on different indicators. The most relevant ones do come up. However, and this is something Anders mentioned, the problem we have with this type of approach is that it's not regionalized. Most of you are LCA practitioners, so you know that this is the case for most LCA work. It is not necessarily regionalized, but that is a main limitation when we want to say that it's aligned with planetary boundaries. Of course, it's the implementation of something that would be regionalized at every level would be very complex, but would be ideal to be sure that we are addressing that question, because a product that maybe at the planetary level is not crossing or does not have a high impact in theory on water, at the local level might. For the other two criteria, as I shared with the examples, we have things that were quite satisfactory in terms of dispersion, having different weights for different products, for different impact categories, and the specificity of having different results for those different products as well. So quite satisfactory in terms of what we were trying to achieve through that work. Of course, there have been changes, there have been improvements on the latest methodologies, but that is to be expected. This is evolving science. I wanted to wrap things up with some of the limitations of our approach. I mentioned regionalization, so it is not regional. It looks at the problem globally. However, most issues are regional. or even more local than that. And so a more defined approach in that aspect would be beneficial. The second one, which again, it's a problem that, or a discussion that comes up from time to time when we talk about planetary boundaries, which is how reversible or critical these issues are. So this is particularly important if you think about inertia. So if you look at things like photochemical ozone creation or particulate matter, those are challenges that are very much time bound. If tomorrow we stopped all the emissions that are contributing to particulate matter formation, pretty much in a few days, we wouldn't have any more particulate matter on the air, or just, let's say, natural conditions. For things like climate change, of course, that is not the case. So the question of how reversible things are and the inertia of a phenomenon is key in making sure that we are going in the right direction, and that is not necessarily highlighted in the approach as is. Of course, there are the human health and resources limitations that I was sharing. There is some type of value system in putting this type of approach in place, of deciding what is relevant and what isn't. So this is something to consider overall, because there are more moral and philosophical questions behind them than just purely scientific ones. And the last limitation that I wanted to share, which was more on the cross-cutting issues. The way that we address the development of new weighting values for these indicators in this study was considering that one impact category has one impact either on human health, either on ecosystems, either on resources. Reality is that, of course, some things like photochemical ozone creation or particulate matter or acidification or eutrophication might have impacts both on ecosystems and human beings. And so that is something that we might want to consider if we are looking for a more holistic approach that looks at not only the environment, but also society, and probably makes the link to those developments that Anders was mentioning of defining what is a planetary boundaries, but also what is just for more sensitive populations, for example. This is it for me. I hope that this showed a little bit of how it can be applied, how it can be used on a more concrete case, and I'm very happy to answer any questions that you might have.
Thank you very much, Martial. So far, there is no question in the chat, so I will ask one because I have many questions. But I think one of the first is close to, let's say, to something you already mentioned in a way. Is that for me, I feel very, very useful the approach you have shown, and I wonder if you believe that, for example, at PEF level, it will bring value and how to promote it, and yeah, what is your intention regarding that? What have you done already? I'm sure you have done already some things.
Yes, absolutely. So yeah, I alluded to it a little bit. So PEF and the commission are well aware of this work. I saw some of the people in the commission here. As I said, the Serena Sala especially has been quite involved in some of those discussions. I have had a few chats with her around this. As I said, they have worked on improving them and developing new ones that they have tested as a comparison to what is being suggested today. I think that it's a question of also what companies are testing as part of the PEF, what they are pushing for. We are having those discussions still, more generally speaking. So I don't know how many of people are aware of this. We are involved right now with this project, a coalition called the Eco Beauty Score. So these are cosmetic companies that got together and decided to develop a scoring system for cosmetic products. And so that the question of this, of what is the weighting system that makes sense, it is a key element of that discussion. So considering, do we want to go into planetary boundaries, something like PEF, the new version of planetary boundaries? So those are ongoing discussions, and we are trying to give our 2 cents at least.
Yes, thank you. There is one question from Annabelle Barthaud. You showed a slide regarding the normalization factors. Can can you elaborate a little bit on what you have used and so on?
Yes,
it was one of the first slides. Yeah.
I did not go into the technicalities of how it was developed. I don't want to go too technical today, but I'll try to give a high-level description. So what was done is that in order to define the weighting system, what we decided was to see how far the average European was to the target, pretty much, if I make it simple. And so what we did is that we first needed to normalize by the average European impacts, which was what PEF was suggesting at the time as a normalization factor. And so the values are looking at it from that perspective. So how far is the average European emissions from planetary boundaries? So that's the logic behind it. And so the first prioritization was based on where are Europeans mostly emitting or contributing to these impacts.
Yeah, thank you. And really, the following question from Joachim Jussen is really something to elaborate a little bit more, because he thinks, okay, how do you consider the influence of this normalization factor on the global single scope?
Absolutely, it does contribute. We know that it does, and especially for the ecotoxicity part, which I explained in part as methodological decisions. But one methodological aspect to it is the normalization factor, because the normalization factor is actually very high or very low, depending on how you look at it. But it does contribute a lot. And so it means that a lot of products, when it comes to normalization, have a very high ecotoxicity impact. So that also plays with the description I was providing before. But at the same time, it is logical. We wanted to make it logical in the sense that at the end of the day, the weighting factor kind of corrects the characterization factor because that was the logic behind it. So that's why I didn't go into the technical details, because no, but you are right to ask the question, because again, we are not just adding a different layer. We add a layer that tries to correct the normalization factor and make it really specific about planetary boundaries instead of the other way around.
Yeah. Thank you. A question from Vincent Debeau regarding, let's say, I would say the update and evolution of these factors. When he covered the 2019 publication, the values were slightly different from what we have today. And on the overall aspect, is it another database to update regularly and taking into account the evolution of the science and planetary boundaries behind?
Oh, absolutely. I do think that there are improvements. So yes, there have been changes that were made since the publication in 2019, linked to different changes that were made by PEF on normalization factors. Particularly, they updated those in the meantime. So we updated the values as a consequence as well. There were also some changes on the fact that, for example, at PEF level, they decided to split. At the time, they had one single resource indicator. They decided to split them into. So you'll see there were two in the presentation I had today instead of just one. So all of that leads to slight changes on the values that were in the initial publication. That does lead me to answer also Emmanuel's question. So yeah, the factors that were shown, yes, are publicly available because there is a scientific article that you can find quite easily, hopefully. Otherwise, send me an email. I'm happy to provide. That shares them. Those are not the latest version I just shared. Those are not public, as you know. In order to make it public, especially through scientific publication, it is quite a lengthy process. So we have decided not to go in that direction, but that is something that we can discuss offline as well.
Yeah. Thank you. Then the comment and question from Jacques, and thank you, Jacques, also for being there and making the link with Martial. So Jacques says, thank you for the clear presentation, and I guess we agree with that. And do you think SALA and planetary boundaries should be used in PEF in the near future? Because replacing panel-based value. So Jacques goes a little bit further than I was going before.
Yeah, unfortunately, I cannot say. Personally, I am not as involved with PEF as I was once. There are some of my colleagues that are, but I don't know. To my knowledge, there haven't been any recent discussions on updating the weighting values. So I don't think that is something that is on the table in the short term, at least. I know that the question that you're raising is a question that does come up frequently. A lot of people question the panel-based values for all the reasons I was describing, but it is not, I mean, again, it's a political institution overall, so it's not just as easy as deciding to do something differently.
Mm. Thank you. And also, can we expect that some regional, as you mentioned it, planetary boundary will be available soon, or I don't know?
Good question. I am not developing them right now. That is not on my to-do list. But Anders, I think you did provide some insights in that space. So I don't know if you wanna add something to what you already shared beforehand.
Well, I can elaborate a bit. A few years ago, I did a postdoc project that was in collaboration with Unilever, and the scientific papers coming out of that had a focus on spatial spatialization or regionalization. But it was in the context of absolute sustainability assessments, so it was not in the context of weighting factors. But I imagine that some of the outcome of those papers I presented back then can probably would also be able to feed into development of regionalized weighting factors. But I think I'm also not so familiar with the literature on weighting as maybe Marshall is. But I think there are a bunch of questions on how you even do conceptually, how you do regionalized weighting.
Yeah.
And I've seen some recent literature on this. I know there's a working group through the GLAM project that are working on developing weighting factors, and they are also considering planetary boundaries as one option. I think the goal of that project is not to develop one set of weighting factors, but to come up with a tool for helping decision makers choose weighting factors, and then maybe have some sets to choose between. So that's also interesting to see what will come out of that. And I do think they have been having discussions about regionalization as well, if I'm not mistaken. So that's the GLAM working group on normalization and weighting, I think is the name. Might be useful to check that out.
Yeah, and to build on what you're saying, Anders, I think that there are two additional elements I want to point. The first one is that the other point that we need to consider is the integration itself, because what we know right now with regionalization in LCA is that we are not very good at actually implementing it because the databases and tools are not adapted to that amount of calculation and work. And so we could develop something, but then what is the actual applicability of it? It's a whole different question. And the second one is that in practicality, maybe not as weighting factors, but as a way of thinking, that is already what we are kind of trying to achieve when we talk about regionalization of impacts in LCA. So when you look at methodologies like AWARE, a lot of the questions that they try to address with the characterization factors that they developed are actually on planetary boundaries. So what is sustainable use of water in each location overall? So there is already work being done in that space around that type of thinking.
Yeah. And by the way, I put in the chat the link to SCORE LCA applications, since we did some studies on how to couple geographic information systems to LCA and make a more accurate regionalization, and sometimes maybe based on open source tools and not on the current, I mean, the one we use every day, making strong coupling or, yeah. So yeah, it's not easy to develop immediately. Yeah.
Yeah.
Okay. So we have another question. Can we expect from Kawei Wong? Can we expect the factors for the biodiversity and novel entities as well?
Well, I would say that goes back to the philosophy that Andrew was saying, whether we are looking at LCA and trying to put it in the planetary boundaries framework or the other way around. Right now, we're done mostly that. That's the way that the work that we focus on was mostly on what are the LCA indicators and what does it mean to put them in the planetary boundaries philosophy. And so, as you know, in LCA, we don't have novel entities indicator, which mostly would fall into ecotoxicity and human toxicity impact categories. Neither do we, or we kind of do now have for biodiversity, but usually they're already an aggregate of other impact categories. Yep. And so doing that work would require some engineering or retro-engineering on one way or another. And again, I have not seen anything being developed in that space recently. For similar reasons, I would say that to what I was saying before, it's a question of applicability, because then that would mean creating an entire novel entities indicator, which again does not necessarily fit into the current philosophy of LCA, and or for biodiversity, which does fit a little bit more, but that's an aggregate of impact categories, and so it's a little bit further down in the cause and effect chain.
I know that some of my colleagues at the Technical University of Denmark, they are working on further operationalizing the novel entities boundary within absolute sustainability assessment. But I'm not sure if they are also thinking in terms of weighting factors. But because I agree with what Marcel was saying, that weighting factors are mostly, I think, applicable to the existing list of LCIA midpoint indicators. And so, yeah, there's no specific indicator for novel entities. It's something that has specifically originated in the planetary boundaries framework.
Yeah, and in addition to that, the other piece where it would be difficult, because you're right, Anders, and that one thing that you did mention earlier is that actually the threshold for novel entities that was determined is pretty much a non-threshold.
Yeah, it's relative. It's not absolute. Yeah.
Yeah, it's relative. It's not absolute. So it does not actually lend itself to define a boundary because there is no clear threshold on what it means.
Yeah.
Okay, is there still questions? I don't see. So, I wanted to thank again Anders and Martial for the very interesting, clear, and good presentations and discussions. Thank you very much. And,
thank you, Richard. Thank you, Philip, for the organization and for inviting us. It's been really exciting to have this this conversation and to have the good discussions also coming out with questions.
Thank you.
And thank you all participants to attend this workshop. And